Good morning, Year 12 Physics students. We're moving on to torque today, and things get a little bit more challenging, so we'll take it slowly. Okay, first thing about the torque is the symbol is a curvy T like that, which is Greek symbol tau, and it is equal to force times distance. Force will just be measured in newtons, distance will be measured in meters. Therefore, if we want to find out the unit for torque, we just see that the formula is newtons times meters, so therefore the unit will be just Newton meters. If it was force divided by distance, then it would be Newton meters negative 1, but because it's force times distance, it's just Newton meters. So great thing to remember there. Now here's our first one. This is the seesaw scenario. So if you have one person on the seesaw here, this is the plank of wood, this here is the pivot point, they'll be generating a torque which will try and make the seesaw turn that way. Okay, torques are always turning forces. So this here is the pivot, or it could be called the fulcrum. Okay, so it's got two different names, the pivot or the fulcrum, or the axle maybe. Could be the axle. So in different scenarios. So that there would try and make it go that way. So in order to balance it, we could put somebody the same size over on this side here. Same size at the same distance. Or we could extend out our seesaw like this. And we could actually put somebody who's a little bit smaller way out further away. So this is a scenario that mums and dads have to do when they play on the seesaw with their children. If you're much larger, then you need to sit closer to the axis or the pivot. If you're smaller, you need to sit further away in order to get it to balance. For this one here, I'm going to put a larger person and I'm going to put them closer to the pivot point, and that there will kind of balance it out. We're going to be using this formula here in a complicated way in order to do all of these calculations in the this week. It'll be coming week. So that's one scenario that we get. Another scenario is the spanner, and this one here is a simple one where a spanner is got a force applied to it. So a hand could be coming down here. Here's our hand coming down, and the hand is pushing. There's the fingers. So the hand is pushing the spanner, and notice that I've drawn that force vector at 90 degrees to the spanner. So for that scenario, it's 90 degrees. This here is the axis or the pivot point, and our distance value will be this distance here from there. That there would be the distance that we put in. We'd have to convert it to meters most of the time. Here's another scenario. This one a little less obvious. This is the classic pirate scenario where you've got your person walking the plank and the person is generating a torque. Now for questions like this, it's not obvious where the pivot point is, but it's actually the edge of the boat. Here's the boat, and that there would be the pivot point on the edge of the boat. Okay, it won't be drawn for you. You'll just have to work it out. The person is generating a force, which will be their weight force. So there'll be scenarios where you have to go force weight is equal to mass times gravity. They'll just give you the mass. You'll need to convert it into a force by timesing it by 9.81 there. And the distance that you'd be working on would be this distance here. There will also be scenarios where they'll say, actually, the plank is also got some mass. And you say the plank is 20 kgs maybe. You would need to work out that the mass of the plank acts from its center. So that's the middle point, halfway from there to there. And that there could be the force weight of the plank. This one here could be the force weight of the person. Okay, so those are two forces. They've got different distances. The distance from there to there would be the plank one. The distance from there to there would be the person's distance. So for this kind of scenario, you've got to add the torque of the person and the torque of the plank, and that gives you an overall torque. Now to our fourth style. This is one where we've got to start using our trig. Instead of pushing perpendicular in that direction, like we did up here, where we actually pushed at an angle, which was perpendicular to the spanner, this scenario involves what happens if you just push straight down and you apply the force straight down. I'll draw it all the way down to here. For this scenario, okay, so they've pushed straight down instead of pushing at 90 degrees to the spanner. The distance value that you use is the perpendicular distance, which is this distance in here. So for this kind of one, they might give you the distance of the spanner. They'll give you this spanner distance here. Like that. They might say that there is 30 centimeters. So if that one is 30 centimeters, you can see that this one is significantly less. So to solve, the other thing they'll have to give you is the angle in here. So they'll say that angle there is 70 degrees, for example. So now you've got to use your trigonometry in order to find this distance here. The hypotenuse is 30. The adjacent we'd work out with trigonometry. So I'll do that for you now. So ka toa, and we're dealing with the hypotenuse and we're dealing with the adjacent. So it's going to be a cos question. So cos angle 70 is equal to adjacent divided by hypotenuse, which is going to be adjacent. We're just going to call it x because that's what we'll call it d. We're sticking with the symbol that's in the formula up here. We've got a d. We're trying to find out the specific d for this question. So d goes in there. Instead of h, we put in 30. All right, now we've got to rearrange it. D will be equal to cos angle 70 times 30. And that gives us an answer of 25.9. And that's in centimeters. When we come to work out torque, remember it's got to be newtons and meters. So to find the torque here, torque is equal to force times distance. We need to know the force. I'll say that the force here was 45 newtons. So therefore we put 45 in there and we times it by the distance, which has got to be into meters, which is 0.259 meters. And that gives us a torque of 11.69. And you can see I've only got two significant figures there, 2 there. So therefore our answer will have to be 12 Newton meters.